Hi, in this section, we want to talk about the parametric equations. Parametric equations are the equations that are given by x of t and y of t, where t is the independent variable of time. So for parametric equations, we always have two equations, one for x and one for y, and both of these are equations based on the variable t, and t represents the time. And if we replace numbers for t based on the time or the interval that's given to us, we will find points of x and y and order pair of x, y, which we can use those order pair to graph. So parametric equation, as we said, there are two equations, and both of the equations of x and y are based on t, and they are describing motion and direction, both of them. Okay, changing the location and the direction of that also. So we always have t, which represent times as a number in an interval, as an integer interval. And we will have a plane curve when we have sets of order pairs x and y, which x and y, both of them are functions of t. And the variable t is called the parameter, and the equations of x and y are called the parametric equations. For example, I have x equal 2t, y equal t plus 1. Now I have the parametric equations because I have two equations, one for x, one for y, and both of them are based on t. And since the t is representing the time cannot be decimals. So if they ask us that the t must be an interval of 0 to 5, that means t can be only 0, 1, or 2, or 3, or 4, or 5. That's it. These are the numbers that can be replaced for t. Now, how we can graph any plane curves? So we need to find the values for t based on the interval, the given interval, and then we replace numbers for t into both of the equations of x and y. And after finding the x and y for each given t, we will find order pair of x and y. And then we can graph the order pairs in the coordinate plane and then connect them to each other. But remember that we are plotting the point in order of increasing. That's why we show the direction. So from the minimum to the maximum number that the t can have, we show the direction of the curve. For example, we want to graph the plane curve defined by this parametric equation, and it says that the t must be a number between -2 to 2, which means you can only replace numbers from -2 to 2 for t. And if we want to graph, we need to have x and y. So we need to, in step 1, we need to find values for t to replace into these equations. And the values that we can have for t based on this interval that's given to us are -2, -1, 0, 1, and 2, only integers. All the integers from -2 to 2, and this equal sign means that the 2 and -2 also must be included. Then we will replace these numbers for t in both of the equations. For example, you can replace -2 for t here for the first equation, and also replace -2 here for this equation. If you replace -2 for the x, -2 squared is +4, +4 plus 1 is 5, and so x must be equal to 5, and if you replace it for the y equation, 3 times -2 is -6. So y must be equal to -6. Now you can rewrite the order pair, x is first and y is second. So now we have an order pair of 5 and -6, and we use this point to graph the curve. So we have to repeat all these steps for all of these values for t. For -2, for -1, for 0, for 1, and for 2. and you can see them all in this table. So if we replace -2 for t in both equations, we get 5 and -6 for x and y. If we replace -1, we get 2 and -3. If we replace 0, we get 1 and 0. Replace 1, we get 2 and 3. And if we replace 2, we get 5 and 6. Then in the coordinate plane, we start graphing and finding these points, or plotting these points, and then connect to each other. So let me do that here. So the first point is 5 and -6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. That's the first point. 2 and -3. 1 and 0. 2 and 3. And 5 and 6. And we have to connect them based on the order of the points. And since we started from this point, so the direction is this. That's the direction. So for parametric equation, we show the motion, how it moves, and we show the direction. If you can see the graph in this picture as well. But don't forget to show the direction. Always for parametric equation, we show the direction by just putting an arrow based on the direction of the points. Next example, we want to graph the plane curve defined by these parametric equations. Again, t is an interval from -2 to 2. So we are going to replace this number for t, find x and y, and then plot the points and graph the equation. So you can create a table if it makes it easier for you. So all the numbers for t from -2 to 2 are -2, -1, 0, 1, and 2. Then we need to replace t for both of the equations x and y and find those and then rewrite them as an order. If we replace -2 in this equation for x, we get -2 plus 2, which is 0. So let me just... We get -2 plus 2. And if we replace -2 in the second equation, we get -2 squared. And -2 plus 2 is 0. -2 squared is just 4. If we replace -1, we get -1 plus 2, which is 1. And if we replace for the y equation, we get -1 squared, which is +1 again. If we replace x by 0 with t by 0, we get 0 plus 2, which is 2. And if we replace into the second equation, we get 0 squared, which is 0. Replace 1 for t. 1 plus 2 is 3. 1 squared is just 1. Replace 2. It's 4 and 4. Now we can plot the points on the coordinate plane and graph the curve. First point is 0 and 4. 1 and 1. 2 and 0. 3 and 1. 4 and 4. So connect the points and show the direction. And that's a graph of these parametric equations. And you can see we get a parabola. So how do we know if these two parametric equations represent a graph of parabola? By eliminating the t. So if we eliminate the t out of these two equations and try to find an equation based on x and y, we can easily see that this graph is exactly the graph of that x and y equation. So we need to eliminate the parameter which is t, and write one equation based on x and y, which is equivalent to the two parametric equation. So now let's see how we can do that in the previous example. If in this example I want to eliminate the t, what we can do? So I have two equations, one for x, one for y. I see that the easiest one is x. I need to solve this equation for t. When I say solve for t, means find t, or have t by itself on one side and move everything else to the other side. If I want to keep and isolate the t, keep the t by itself on the left side, I need to move 2 by subtracting 2 from the both sides. So the t must be equal to x minus 2. This equation tells me in the second equation, I can replace the t by x minus 2. And if I replace the t by x minus 2, I get y equal x minus 2 squared. Now I eliminated the parameter, which is t, and I have an equation based on x and y. This equation, that's exactly equivalent to the parametric equations. And this equation, that's a quadratic equation, and it tells you that you must have a parabola with the vertex of 2 and 0, because we have 2 here and no number here. And you can see that we exactly have a vertex, a parabola, and the vertex is 2 and 0. But since t only defined from -2 to 2, it changed the domain of this function as well. So that's why, so when we graph this equation, we don't have it all the way to infinity. We have it in restricted domain. Let's look at another example. We want to eliminate the parameter in this equation and then find an equation based on x and y and then graph that equation. So it sketch the plane curve represented by the parametric equation by eliminating the parameter. So again, I have two equations, one for x, one for y. So in previous example, I tried to find the t from one of the equations and replace it into the second equation. But in this case, both of my equations are based on cosine and sine. And if I want to find t from each of these equations, I need to use inverse sine or inverse cosine, which makes it a little complicated. But I think I can use one of the trig identities. When I see I have two equations, one based on sine, one based on cosine, the only identity that comes to my mind is that the sine square plus cosine square is always equal to 1. So it means that if I can find sine square from this equation, sine from this equation, and the cosine from the first equation, and replace it into this identity, I can have an equation which the t is eliminated in that. So what do? We need to find sine from the second equation and cosine from the first equation. So if I want to find the cosine from the first equation or isolate the cosine, I need to divide both sides by 6. Now we say that the cosine of t must be equal to x over 6, but since in this identity I need cosine s square, I s square both sides and I get cosine square, which is equal to x squared over 36. We do the same for sine from the second equation. We isolate the sine by dividing both sides by 4, and then s square both sides, and we get sine square, which is equal to y squared over 16. Now we can replace these equivalent fractions to the identity. So instead of cosine square, we replace x squared over 36. Instead of sine squared, we replace y squared over 16, which must be equal to 1. And that is the equation that we get. There is no parametric, there is no parameter t, and the equation is only based on x and y. And if you remember from Math Theory A, that this equation is the equation of ellipse. So we have an equation of an ellipse, which the major axis, that's the number under the x, 36, which means we have 6 away from the origin, and the minor axis, 16, which tells us that the minor axis is 4 from the origin. Something like that. So 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4. So if I want to graph the whole ellipse, I get this equation, this graph. But I know that the t is restricted from pi to 2 pi. So I need to check which part of this ellipse I have to graph, not the whole. Only from pi to 2 pi. So what do? We replace pi and 2 pi to find the minimum and the maximum point in both of these parametric equations. So if I replace pi, I get x, which is equal to 6 cosine of pi. I know the cosine of pi is -1, so the answer is -6. And y, which is equal to 4 sine of pi, and sine of pi is 0, so the answer is 0. So the point that I get is -6 and 0. So which means that I will have this point. That's my first point. If I replace 2 pi, I get x equal to 6 cosine of 2 pi. Cosine of 2 pi is 1. 6 times 1 is 6. Y is equal to 4 sine of 2 pi. Sine of 2 pi is 0. So the answer is 0. So the point is 6 and 0, which is this point. That's the minimum point, starting point, and that's the last point. And that's the direction. So let me show you in different color. So if I want to graph this ellipse, I get this part. And that's a direction. So we will have this graph by just replacing pi and 2 pi to find the lowest and the highest point of the graph, the first and the last point. So next example, we want to graph these parametric equations by eliminating the parameter. Again, we need to try to find the t from one of the equations, which is mostly the x equations, and then replace it into the y equations. If I want to find the t from this equation, I know that the x is equal to a square root of t. And if I want to find the t and isolate the t or get rid of the radical, I need to x square both sides. So I get that t must be equal to x squared. Now, in the second equation, which is y equal to t minus 1, I can replace this for t. So y must be equal to x squared minus 1. Now I have an equation with only x and y. How we can graph this equation? I know that this is a graph of a problem because that's a quadratic equation again. So if I want to graph it in normal, just plane coordinate plane, I will have a parabola which is shifted 1 down. So that should be something like this. But not the whole thing is in this. We need it because t is restricted from 0 to 2. Let's replace the 0 and 2 in both of the equation and see what do we get. If I replace t by 0, x is the square root of 0, which is 0. Y is 0 minus 1, which is -1. So the answer is 0 and -1. If I replace t by 2, x is equal to the square root of 2, which is 1.4. if you put it in calculator. And in the second equation, y is equal to 2 minus 1, which is 1. And the answer is 1.4 or root 2 and 1. Which means that I only need the part of this graph which is from 0 and negative 1 to 1.4 and 5. 1.4 and 1, something over, because this is 1, if this is 2, that's 1.4. So I only need this part of the graph. So this blue one is the graph of the equation, and that's the direction. So for graphing this one, I only need that's 1, 2, 3, 1, 2, 3, 1, from negative 1 and 0, 1.4 and 1, and I know that's going down to negative 1. That's a graph of these parametric equations. Next example, we want to sketch a plane curve that are represented by these two parametric equations. Again, as you see, x and y, both of them include Greek functions, sine and cosine. So whenever you see three functions, try to find one Greek identity. And the only Greek identity that I know that includes both of the sine and cosine are sine square plus cosine square is equal to 1. So I just need to find sine and cosine from each of these equations and then square them and replace it into this identity. If I want to isolate the sine from this equation, I just need to divide both sides by 2. So the sine of t is equal to x over 2. I need to square it. Okay, square both sides, and we get x squared over 4. I need to find cosine from this equation as well by dividing both sides by 2. So cosine of t must be equal to y over 2. And if I square it, I get cosine squared, which is equal to y squared over 4. Now I'm going to replace these two for sine and cosine squared in this equation. So x squared over 4 plus y squared over 4 must be equal to 1. Since these two numbers are exactly the same, I can multiply the whole equation by 4 to get rid of all the denominators. So if I multiply each of these terms by 4, I get x squared because 4 and 4 cancel each other, plus y squared because again 4 and 4 cancel each other, but 4 times 1 is just 4. And based on my previous knowledge, I know that's the equation of a circle. A circle which the radius is 2. So if you want to graph this, you will have a circle with radius 2. But do we need the whole circle? No, because t is restricted from 0 to pi. So we're going to replace 0 and pi to find the first and last point of the graph. If we replace t by 0, the first equation x is 2 sine of 0. Sine of 0 is 0. 2 times 0 is 0. Y is 2 cosine of 0. Cosine of 0 is 1, and 2 times 1 is 2. So we have 1 point, which is 0 and 2. If I replace t by pi, the first equation x is 2 sine of pi. Sine of pi again is 0, so the point is still 0 for x. And y is 2 cosine of pi. And I know the cosine of pi is negative 1, and 2 times negative 1 is negative 2. So means that, well, my first point is 0 and 2. My second point is 0 and negative 2. But which side? The right side or the left side? So what point do we have between 0 and pi? Between 0 and pi, we have pi over 2. Let's replace t by pi over 2 as well. Let's see what do we get. If I replace t by pi over 2, x is equal to 2 sine of pi over 2, which is 2 times 1 is 2. Y should be equal to 2 cosine of pi over 2. I know that's a 0, and 2 times 0 is 0. So we get 2 and 0. 2 and 0 is over here. So I need this part of the graph only, just this blue part, but that's my first point, and that's my last point. So that's the direction. So the direction of this parametric equation is this one, and you can erase other part. Now we have the equation, the graph of the equations. So as you saw in the previous examples, we had the parametric equation and we were able to eliminate the parameter or eliminate the t to find an equation based on only x and y. But now, sometimes we may have an equation based on only x and y, and they ask us to find the parametric equations. So what do we do in that case? For example, I have y equal 2x minus 1. That's an equation only based on x and y, but now I want to define one set of parametric equation that's equivalent to this one. So what do? We need to replace x by t. So the first equation that I define is always x equal t, which means replace the x by t. And the second equation, which is y, because all of the x and y equations are always y equals something. That's right, y equal a function based on x. So when you replace x by t, you will have your equation, your y equation based on t, because you're replacing x by t. Now you have two equations, and these two are the parametric equations that are equivalent to that equation. So we assume that the first equation is x equal t, replace x by t in the second equation, and we get another equation based on t for y, based on the rectangular equation. Now let's look at an example. We want to find a set of parametric equations for the parabola whose equation is y equal x squared minus 25. So first step, we replace x by t. Okay, so that's your first equation. Always, that's your first equation. Now you only need to find the second equation, which is an equation for y. So if you replace the x by t, what do we get? We get y equal t squared minus 25. That's it. So that's my first equation, and that's my second equation. These are the two equations, the two parametric equations equal to the parabola equation. So every time you are writing parametric equations, you need two equations, one for x, one for y. You always assume x is equal to t, and you only need to find the equation for y. And the last question, we want to find the set of parametric equation for this parabola. Again, the first step is setting x equal t. Now find an equation for y. If we replace x by t, we get t squared plus 4. Now we have a sets of equations, sets of parametric equations. We have two equations, one for x, one for y. They are both based on t, which is represent the time, and these two equations that are equal to this parabola equation.